we are on to the first derivative test. So let's see what these first couple sentences say here. Suppose that f is a continuous function over an interval I. So that means over this interval, we can sketch the function, right, without lifting our pencil. And in that interval, there is a critical point C. So this is some point where either, right, the derivative is 0 or the derivative does not exist. If f is differentiable except possibly at C, then f of C satisfies one of the following descriptions. And so the first description here is if f prime changes sign from positive when x is less than C to negative when x is greater than C, then f of C is a blank of f. Well, let's just think about that. If you were to maybe sketch in a set of axes, and I'm going to sketch in actually two sets of them. There's one. And let's do one more. And we're going to put x equals C on both of these. There's really going to be two scenarios that we could really sketch here. Let's call that C, and maybe this will be C here. So if f prime is positive, right, that means that the function is increasing. And if f prime is negative, that means that f is decreasing. So this thing is increasing, okay, before we get to C, and then decreasing after C. So if we were to sketch it, let's maybe just pick a point here. It would be increasing. And then when it gets here, it levels off and starts decreasing. But this isn't the only way that this could happen, right? This would be if it was differentiable here, right? But it says that it doesn't actually have to be differentiable at this peak here. Okay. So it could also maybe be like a sharp corner here. But the point is we go from increasing to decreasing. And is what that tells us, if we go from increasing to decreasing, is that we have obtained a local maximum at x equals C. Right, and let's think about a slightly different scenario here now. Let's think about maybe going from negative, so the first derivative is negative when x is less than C, to positive when x is greater than C. And let's sketch a picture of this to try and envision what's going on here. And again, there's really two situations, one where maybe it's differentiable at C and one where it's maybe not. But overall, that doesn't change our picture here a lot. So maybe this time I'll just include one picture. And we'll say x equals C again. And this time we want to go from decreasing to increasing. So if we're to do that, decreasing to increasing. And so all that's happened is we obtained a local minimum at x equals C. Local minimum. Now, if the sign does not change at x equals C, and when I say the sign change, I'm talking about the first derivative. So if the first derivative doesn't change sign at x equals C, then it's not going to be a local minimum or maximum is what this last one's saying. And you might be trying to envision, well, what would that maybe look like? Okay. Let's see what this might look like. So there are these things called inflection points that we're going to talk a lot more about in the next section. But graphically, it's what these look like. And you can see it looks like it's about to level off here, right? And then it just starts going back up. So kind of like a cubic here. So this is one of those spots where maybe you can see f prime of c is 0, but we're increasing to the left of it, and then we're increasing to the right of it. So this isn't a local maximum, and it's not a local minimum.